much.
Hi everybody, this is Mr. Folly and welcome to podcast 4.2. We're going to talk about percent composition, compound ratios, and molecular eye of reactions. We've done a little bit, so it shouldn't be too bad. So let's see if we can just fire it up. Mixtures can have a different percentage of each part. Remember we talked about this a bit with the brick. So I like my coffee with 2 sugars and 3 creams, but you, not you. The biggest coffee drinker I think in the world is Faye. Faye likes hers with 0 sugars and 1 cream, but they're both coffee. So mixtures can have different ratios of it. The percentage of sugar is different. The percentage of cream is different. The percentage of original coffee content is different. And we're going to talk about this in terms of ratios for compounds. Compounds have the same ratio. 100 grams of water is 11.2% hydrogen. So if I were to do a ratio of that, which I'm going to do in a minute, it would be the same ratio of hydrogen to oxygen. 250 grams of water is 11.2% hydrogen. Hey, look, this is often shown as ratios. So if I were to do that, I would say 11.2 grams of H over 88.8 grams of H. Or if I had 250, I had to do a little math magic here. 28 grams of H over 222. No, don't do that to me. Don't do that to me. Come on, you cannot do that to me. 222 grams of. Oops, I put H over O. Okay. If you have a mass ratio of A over B as 2 over 1, the formula would be A over B. Okay. So let's take a look at what that means. This one's a So compound 1 is 66.7 grams of S and 33.3 grams of O. Compound 2 is 50 grams of S and 50 grams of O. Find the ratio of S to O in 1. So what I'm going to do is I'm going to do S over O in 1 is going to be 66.7 over 33.3, and that's going to be 2. Okay? This is compound 1. Compound 2 is going to be S over O again, which is going to be 50 over 50, which is going to be 1. Okay? How do these ratios compare? Get back here. Get back here. I swear I can write this word. Twice as much as. So, what's the likely formula? Likely formula would be for compound 1, get back here, 1 would be S2O, and for 2, it would be SO. That makes sense? I have twice as much S as O. So there you go. So those are likely formulas you can figure out for them. Compound 1 is 75.83 grams of carbon and 25.17 grams of H. Compound 2 is 85.6 grams of carbon and 14.4 grams of H. Determine the mass ratio of, whoops, I did 1 over 2. I wanted to say C over H. Okay. So I'll do 75.83 over 25.17. So 75.83 divided by 25.17 is 3.01. And then the other one is 85.6 over, get back here, 14.4. Can you guys please just not be louder than me? Thanks. 85.6 divided by 14.4 is 5.944. So now, determine the mass ratio of carbon over hydrogen in each of these. How does the ratio of 1 compare to the ratio of 2? Well, if I have 3.0 divided by 6, rounding to 1, right? Ish, would give me 1/2. So what that means is I would have, this is carbon, this is hydrogen, I would have 2 times as much for these ratios, okay? So this one might be, so compound 1 might be, oh, I can't believe that just went away, and I don't remember what it was. Okay, so I had 3 carbon, so 3 for number 1, and I had 6 for number 2. So that means that number 1 was likely C1. Number 1 had 1 C and 1 H, and number 2 had 2 C's and 1 H. So this would have twice as much. So this way we can individually figure out how many carbons there would be in each one. And now you won't change screens. Remember the diatomics, elements that come in pairs when alone, Hunkelbrook. We'll give you a box for each reactant molecule, but we'll often leave out boxes for the product. So hydrogen, I'm going to use, you get to pick your own symbol. Pick symbols. Simple symbols, not pentagons. So hydrogen, I put a hydrogen in there. I put a hydrogen in here. And over here I have oxygen. I'll make that a double box. Because they're diatomic, I put them in there. So this means my products, I've got to use up all of these pieces. There's a box. If I tell you it's H2O, I've got to have 2 H's on 1 O. Let's get back here. Then if I have another one, see how that would get rid of this one? And then 1, 2, 1, 2, 1, 2, 1, 2. So my final answer would be not crossed off. Box with the ears, box with the ears. Okay. Alright, I had another screen that just went away. So weird. Let me see if I can pull it up here. Let me just go back to it. Ooh, do I have a blank screen? I don't. So let me do this. Get out of here. And I'll get myself a new one. Insert slide. Okay, so here's my new slide. So what I'm going to have is I'm going to have Ca plus O2 is going to give me CaO. Okay. Now in this one I'm going to have 2 boxes of calcium plus 1 box of oxygen. Get back here. I already did that one. Where'd it go? I did not just lose my screen. That's interesting. Okay. So calcium, since I gave you 2 of these, I'll make calcium a star. It's whatever it is. And oxygen is going to be diatomic. Now CaO is going to have my star attached to a circle and another star attached to a circle. That'd be it.
Good morning, Melody.
That's it. Toodles.
At this time, please join me in observing a moment of silence.